In this video, we're going to talk about the LSA Type 4 and the LSA Type 5 on OSPF in Cisco IOS. The idea here is to look at our topology, do a couple of different things, and see what happens in every step of the way. And the idea is to solidify the understanding of what actually happens, why we actually need the LSA Type 4, what actually happens with different types of LSA 5s, with both the metric type E2 and the metric type E1, using a couple of very concrete scenarios. So the first thing that we need to understand is, remember why we actually need the LSA Type 4. Remember that what happens when we are actually introducing an LSA Type 5 into the network. When we introduce an LSA Type 5 into the network, what's actually happening is that we are putting into our OSPF domain external routing information. So routing information that we learn from another source, another routing protocol, maybe statically configured, that's been introduced into OSPF. So in order for OSPF to provide that information into the database, we basically get that LSA, which indicates the typical things that you would expect, such as the actual network, the subnet, who originated that information, the metric, the network, the metric type, if it's E2 or it's E1. So one interesting thing there is we are putting into that new LSA the originator router ID. So if I am a router and I put that into an area, what happens? I'm putting my router ID there. Remember what's the issue with router ID? Router IDs are not a subnet, they follow the same format, but in reality they are just an identifier. So what happens when we go across an area? When we go across an area, the only information that gets sent in the LSA Type 3 is basically prefix, the prefix, the mask, the metric, and that's it. There's no topological information, there's no router ID information, nothing like that. So what would happen is that an LSA Type 5 would go across an area, and now the router in the new area does not know how to reach that particular router ID because that router ID doesn't exist in his area. So in order to solve this issue, we have the LSA Type 4, which basically provides this information. It's giving them, the routers in this new area, the information on how to reach that particular router ID, which typically means send traffic to an AVR, and the AVR knows, the AVR is connected to the area where that particular ASVR exists. So he will be able to forward that traffic on. So this is an important thing to remember. So let's actually jump into our devices, jump into our topology, and let's start configuring, and this will be a bit clearer. So let's look at our topology. This is a topology we're going to be basically using. The right side, where that's tagged as external, is basically running another OSPF process. So they're going to be running, all of our diagram is running OSPF 1, and the ones on the right are running OSPF 2, which basically will serve as an external source of routing information. It will be the exact same thing as, for example, if we were redistributing REP or another routing protocol, BGP or something like that, into OSPF. And the idea here is that router 7 and router 6 are going to be our ASVRs. They're going to be the devices that are putting external routing information into OSPF. And we have two areas. The area in the middle is basically our backbone area, area 0, and on the far left we have area 1. So all those routers there, router 4, router 5, router 2, are going to be living in area 1. So they're going to require that LSA Type 4, because what's going to happen is when we do redistribution, for router 1 and router 3, this will not be an issue, because when they see those new LSAs injected into the database with the router ID of router 7 and router 7 and router 6, they will be able to know where that router ID lives, because basically they're in the same area, so they have all that information using the LSA Type 1 and the LSA Type 2. So they won't have any issues. But what's going to happen is that information will get sent across the AVRs. So that information will get sent like that as an LSA Type 5. Same here, same thing on router 3. And for example, router 2 will not know what to do with that, because he will not know how to locate that. He doesn't know where on that particular area router 7 or router 6 exists, because he doesn't have that topological information. Because when also router 1 and when also router 3 send information about, so that would be an LSA type 3, and the same thing here. When they send that information over to area 1, they are suppressing all that topological information. They're basically just sending the subnet, the mask, and what's the cost from their perspective to reach those subnets. So from router 2 in fact doesn't really know if we have 2 routers, 10, 20, 50, or any amount of routers inside area 0, and that's the whole idea of having this segmentation of areas. So that's where the LSA 4, will come into play and provide that information on how to reach this particular router ID. So let's do some configuration here. Let's start with redistributing everything that's in that OSPF process 2 on router 7 and router 6, and it's going to be basically those subnets that we're seeing there to the far right. So we're going to be doing redistribution in this direction, and that's obviously going to start, and that's going to create all those LSAs type 5, and when it gets to R1 and R3, are going to create those LSAs type 4, besides actually sending the LSAs type 5 over to area 1, which make it over there intact. They really don't change at all, and that's a characteristic that they have. So let's actually go ahead and do that. So we'll jump into where we are. We're in router 2. We'll jump into R7. We'll do router OSPF 1. We'll do redistribute OSPF 2. Let's give it a metric of 100 subnets. And if we don't specify anything, by default, they're going to get redistributed with a metric type of E2, which we're going to talk about in a little bit, but basically means, in theory, that only that 100 metric is taken into account, even though there's another metric that we're going to see an example in a little bit. So now R7 is receiving that. Let's make sure R6 is doing the same thing. And we'll do again redistribute OSPF 2 metric 100 subnets. And now if we look at, for example, if we go into R3 or R1, if we do show IP route OSPF, we should see some E2s there, and we are seeing them right there. We are seeing basically 3 routes that we are learning. In this particular case, he's preferring R6 because he's calculating which one is, has a better internal metric to reach it. So if we do, for example, 68.0, if I do route only, not OSPF, we have this other metric that's the actual internal path that's being calculated and used to reach the ASVR. And based on that, we're going to explore that a little bit in a second. He's choosing, even though he also knows about R7, because if you look at the database, if you do show IP, or if I type OSPF correctly, database, and we do external, he's gonna be receiving that information from both sources, and we can see that here. We can see that he's actually getting that particular network via router ID of router 6 and via the router ID of router 7. And they have the same metric. So why he's choosing to use R6, it's basically because of that forward metric that's best. And it's because if we look at the diagram, we're going to have the following costs configured. We have 10 here, we have 10 here. I think that this crosslink between R6 and R7 has 1,000. So from router 3 perspective, he's going to say, okay, so I can reach that either by sending that directly to R6 or by sending it across R6 to R7, which is going to be, so it's going to be 1010 versus 10, that forward metric. So of course it's going to choose the shortest path, which is going to be to just use R6. And this will be much clearer if we actually look at it from router 6 perspective. We should use another color, a better color. Let's use purple there. And also, if you, for example, if you look at, and if we do something like ASVR summary there, we're gonna see that LSA Type 4, which is what actually gets sent over to router 2. And with those is that router 2 is actually going to be able to find those, it's going to be able to locate that router ID, the router ID of router 6 and the router ID of router 7. And we can do it here. We're going to see if we do show IP OSPF database external. For example, let's use that one. You can see that the LSAs are pretty much intact in the same. There's really no change here. You can see there the router ID of router 6. You can see there the network mask. You can see the metric. You can see the metric type. You can see there's no tag. Same thing for the one coming from R7. So that was pretty much sent over without any modification there. And as I mentioned a couple times already, he has no idea, or he wouldn't have any idea without the use of our particular LSA Type 4 about how to reach them. And we can see those LSAs Type 4 there, and basically he's going to get that information. He's going to get from both R1 and R3 how to reach R7 and R6, because remember that R1 can reach those two devices and R3 can do it as well. So it's going to be basically a difference of metric. And you can see it here. You can see the LSA router 1 is basically telling us that he can reach this link state ID, so it's basically a router ID of the router ID of router 6 with a metric of 1010. So basically that's sending it across R7. If we look at our diagram here, that's basically telling it, yeah, sure, I can reach that doing this. And R3 is going to have the same perspective to reach R7. So now the question is, how does it actually look from the perspective of router 2 as we have it now? Well, let's take a look and let's talk about what can happen and why is it doing it the way it is. Let's jump to R2 and take a look at the routing table. We should see 3 E2s, but let's just focus on one of them, and it's going to be exactly the same thing for the other two. So let's focus on one of them. Let's focus on one of them and see what happens. So for example, we can focus on 68.0, and we can see here an interesting thing, which is that basically according to the routing table, we're doing load sharing. We're doing load sharing between the two paths, and you can see there one via R3 and one via R1. And if we look at our diagram, so that's basically because we have the exact same cost. We're injecting those external information, which in this case is this link here. We're injecting that information with a metric of 100, and if we look at the path, both from using R1 to reach R7, we have 20. So basically, if you use R7, we're using 10, which is our cost to reach R1, and then the cost that R1 has to reach R7 plus the external cost of 100, and to use R6, pretty much the same thing. The cost that R2 has to reach R3, and plus the cost that R3 has to reach R6, plus the cost of the external. So these two here will be that forwarding metric, and the 100 will be the metric, the E2 metric. And as you can see in the routing table, all we are really seeing is that E2 metric, which doesn't change. So now it's when the tricky part comes in, and if we do, for example, 10.068.0, you can see there, you can see this forwarding metric, which is basically the metric, the metric of the internal path. You know, what's the cost from R2 perspective to reach the ASVR, which in this case is either R7 or R6. And since that's equal, we are doing load sharing. So when I modify that, we'll go ahead and modify one of the paths. We're going to modify increase cost of one of the interfaces. You'll see how that's no longer valid, and when that's no longer valid, we won't be doing load sharing anymore, even though we're still getting the exact same LSA with the exact same external metric. But it's a distinguish that OSPF makes. In order for you to be able to get load sharing, the internal path has to be equal. So let's go ahead and do that. So we can go into, for example, what do we want to do? Let's go into R3. Let's go into R3 and increase the cost of that interface. So it's 0, 0, IP, OSPF, cost 30. Let's do the same on R6. And now if we check R2, we're going to be seeing that now we are only using R1. That's because we just broke this here. This is no longer true. Now this is 30. So now, since that's not equal, the best path is going to be to use R1. Even though our external metric, it's exactly the same. In fact, if you go into R2 and do show IP OSPF database external, you will see here that we're getting the exact same information. I mean, this has not changed. We are getting from router 7, we are still getting that with an E2 metric of 100, and from router 6, we are still getting it as well with a metric of 100 and as a metric type of E2. But that's something that it's not very well understood and it's not very well explained in most textbooks. It's something to take into account, that if we have the exact same metric and we are doing, we are getting the same information via 2 ASVRs, we will only be able to do load sharing if the internal cost is the same. As soon as we have some variation, we will no longer be doing load sharing. So now you can see, you can understand why. As you can see here, we had this at 10, we increased this to 30, and now basically we don't have that anymore. But this is something that only applies when we are doing redistribution with the exact same metric. So if I go ahead, for example, now and jump into R7 and increase that redistribution metric from 100 to something a little bit higher, like 110, you will see how we go back to the path using R6, because it's sort of a tiebreaker mechanism where OSPF and the iOS are looking for something to distinguish which is the best route available to reach that ASVR, to reach those external prefixes. And in the case we have the exact same metric when we're doing the redistribution, they're going to be looking at the forwarding metric, which is going to be the internal path. But as soon as I touch that, as soon as that's not the case, where the metric that we are using to redistribute that into our OSPF domain is not equal, the smallest will win regardless of what's the internal metric. And let's see that. Let's go into R7 and let's increase that from 100 to 110 or something like that. So I want to go to R7. So we'll do router OSPF. Let's increase these to 110. So now we are going, as you can see that here, we are going via R3 and R6. And basically we are doing that because now by metric we are preferring that the lowest E2 metric that we have, which is 100 versus 110, regardless of the internal path, because we actually look at the diagram. So now this is 110, and now, yeah, that's still 100. So Let me just erase this quickly. So this will be 110 and this will be 30. So this will be 130 if we were looking at the total thing, and this will be 140. So in theory, the path to R6, it's worse. It's worse because, as you can see there, if we sum it all up, it's worse. But since it's E2 and the only thing we are officially taking into consideration is that first redistribution metric, unless the case that we discussed previously, we are preferring now to go via R6, and you can see it there. So that's basically E2. So remember, when we have the exact same metric, we will be taking into account the internal path. So if you want to do something like load sharing, you will need to have the exact same cost to reach your multiple ASBRs. If you don't, then you won't be able to do load sharing. But as soon as we have different metrics, it's the first metric, the metric done in the distribution, what counts. So that's basically E2. Let's talk a little bit about E1. I'm gonna clear that out. Let's do the same thing. Let's just change it to E2. So let's leave that as 110. Let's leave this at 100. Remember that our values here are 10, 30, 10. So cool. Just to wrap up, if you look at the OSPF, the actual LSA Type 5, you would see there. You would see here metric of 110, metric of 100, and that's it. He wouldn't even look at the forwarding metric anymore. He would just pick the smallest one and put that in the routing table. Okay, so now let's switch this to E1. So the router OSPF E1. And we say metric type, specify metric type of 1. Before we actually keep going, another interesting thing is that, well, but still, I should have done it. Let me just modify this to show you something quickly, which is that if OSPF is learning the same information via multiple ASBRs, and one of them is E1 and the other one is E2, he will always prefer E1, regardless of the metric. E1 will win all the time, regardless of what's the metric. For example, we have here that we have a higher metric because the other one is 100 and this was 110. If I change this to E1 and we go into router 2 again and we check what's actually installed in the routing table, we'll see that he will pick them, and you can see there, type external 1, metric 130. He will pick that regardless of what's the case, regardless that we have a smallest one, that's E2. So that's, the preference is always E1 over E2. So just something to show you quite quickly there. And if we, I was going to show the database. And you can see that, we still have, you can see it here. We have the two LSA Type 5, one of them with a metric type of 2, and we can see that it has the smallest metric there. And we have the other one, the one that's coming from router 7, with a metric type of 1, and a metric that's higher than the E2, but he will prefer the E1 over the E2. Okay, so now let's change the other one. So the other one was this. So now we got rid of the E1s, and you can see here that we should have refreshed that, and yes, now both of them are E1s. And if we look at the routing, now we're basically going to continue to choose R7 because it's going to be the shortest path. It's going to be the shortest path because even though we are injecting with a higher metric, he is going to sum all those metrics up. So he's gonna do the calculation that I was doing earlier. So basically, R2 is gonna be saying, okay, so the cost to reach my ABR is going to be 10, and he's reporting that he has a cost of 10 to reach the ASBR, and the metric that's actually been injected is 110, so that gives me a grand total of 130. And going via R6, same thing. What's the cost for me from the perspective of R2 to reach R3? Well, that's going to be 10. R3 reports that to get to R6, it's a cost of 30. and R6 reports a cost of a metric of 100. So that's going to be 140. So I am going to prefer, he's going to prefer to go via the shortest path, which in this case will be via R7. And basically this is pretty much all there is about LSA Type 4 and LSA Type 5 on Cisco. The important thing is to understand why each one of them is needed and to understand those corner cases, those scenarios that I mentioned. There are exceptions and they're typically not very well explained, you know, when we have multiple redistribution points and when we have the exact same metric. I hope this information has been useful.